Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one problem on mesh analysis. The question is determine the current through 10 ohm resistor in the given circuit. So this is a circuit which is given to us and there's a 10 ohm resistor here in this branch. We have to find out what is the current flowing through this 10 ohm resistor. The direction of the current is not mentioned in the circuit. In that case, we can assume any direction we want. But we will talk about the current through this 10 ohm resistor at the end. Right now, because we have to solve this question using mesh analysis, we will try to understand how are we going to apply mesh analysis as an approach to find current through 10 ohm resistor. Till now we have done few questions on mesh analysis. This is going to be a little different from the questions that we have already done. Let us first try to figure out what are the meshes available and where we should be applying KVL equation. So there are total 3 meshes. As we can see, this is mesh number 1, this is mesh number 2, and this is mesh number 3. So let me first of all define 3 currents in each mesh. This is mesh number 1. Let me define a clockwise current. I'm going to call it I1. The second mesh, let me define clockwise current again, calling it I2. And in the third mesh, I'm going to define current I3. All the 3 currents I have assumed in clockwise direction. Now mesh number 1, there is no problem with mesh number 1. I can directly apply KVL in mesh 1. So let's do that. KVL in mesh 1. Let's see what am I going to get. I'll start from this particular point. The first component is 2 volt. Whenever you go from negative polarity to positive polarity, there will be rise in voltage and hence it will be plus 2. Next is 1 ohm resistance. Now the current flowing through 1 ohm resistance is nothing but I1. It is flowing in upward direction. We are also traveling in the same direction. Whenever you travel in the direction of current, there will always be fall in voltage and hence the drop that we write down will be negative. So it will be 1, which is the resistance, into current flowing through 1 ohm, which is I1, minus 1 into I1. Minus, I repeat, because we are traveling in the direction of current. In the direction of current, drop will be negative. So if I want to mention the polarity of the voltage across 1 ohm, the polarities will be plus here and minus here. Okay, next comes the 10 ohm resistance. Now if you observe, we have already written KVL equations in the previous problems. First current that is flowing through 10 ohm resistance is I1 in the downward direction, and the second current that is flowing through 10 ohm resistance is I2 in the upward direction. Whenever there are 2 currents flowing through a resistor in opposite direction, the equivalent current, the overall current through the resistance, is always the difference between them. Now it can be either I1 minus I2 or I2 minus I1. What difference we should take depends on what direction of current I want. So let us say right now, if I assume current flowing in the downward direction. So in the downward direction, if I assume the current, then the current will be I1 minus I2. So I'll just show it separately somewhere. Let's say here, this is my 10 ohm resistance, and the current that I have taken through 10 ohm resistance in downward direction will be nothing but I1 minus I2. So if I write down voltage with respect to I1 minus I2, because this current is flowing in downward direction and we are traveling in clockwise direction, which is also downward direction with respect to 10 ohm, the drop that we write will be negative minus 10 into I1 minus I2. This is all we have. There are only 3 components in the first loop, so this is equal to 0. If I simplify this a little bit, this is minus I1 minus 10 I1. I'll send it on the other side. I get 11 I1. This will be minus 10 I2 equal to, I'll keep 2 on the same side, so that's 11 I1 minus 10 I2. Let me call this as equation number 1. So this is my first equation.